Thank you.
I think I did it right.
I will begin with a word of prayer. So, Dear Father, we thank you for this day and for this limited number of students. Help us to have a good class together. In your name I pray. Amen. I will begin by a limited, yes, but all of the good students are here. See here. two over. You guys can fill out the course evaluations. Everybody else doesn't need to. Let's hear. No, kidding. Mostly kidding. Let's see here. F of x is. So you want me to kind of work through this and see if you get the same thing?
Yeah.
I can do that. So we're supposed to expand about. We're looking for center c equals to minus 2.
Yeah.
So yeah, use your imagination a little bit. This is 6 minus x plus 2. But if I do that, I've just subtracted 2, which means I need to add 2. And once I do that, then I've got 2 over 8 minus x plus 2. And then I factor out the 8. Like that, right? And now I can do geometric series. So 1/4. This is number 6 of section 9.9. Yeah?
Would it have been easier? I mean, would I have been able to take 6 out of the bottom and then do 1 subtract x to 6?
No, because if you do that, then you're going to be centered at 0. See, if you wanted to be centered at 2, you got to create that x plus 2 before you do this. So to center at 2, I got to do a little bit sneaky, this sneaky stuff here. So that's x plus 2 over to the n over 8 to the n. And yeah, that's pretty much it right there. Yeah, I mean, there are exceptions to that. Like, here's one. If I wanted to, say, find the power series for, you know, e to the 3x, and, say, centered at, you know, c equals to 7, then, well, I guess I'm going to say that, I think I'm going to agree with what you just said. That's 3 times x minus 7, right, plus 21. So that would be e to the 21 times e to the 3 times x minus 7. So e to the 21 times the sum, n equals 0 to infinity, 3 to the n, x minus 7 to the n, over n factorial. Now this one, of course, we could also have, we could have done by direct application of Taylor's theorem, right? Because it's not hard to see that the nth derivative of this function is 3 to the n times e to the 3x, right? So if I evaluate that at 7, then that's 3 to the n e to the 21. And so that tells me then that the Taylor series, by Taylor's theorem, sum n equals 0 to infinity, the nth derivative evaluated at 7 over n factorial times x to the minus 7th to the n. Well, what is that? That's, you know, sum n equals 0 to infinity of 3 to the n e to the 21 over n factorial times x minus 7 to the n. Now, this calculation I did right here is something everyone in the class should be able to do. My second solution is not as easy, it's not as clever, but everyone should be able to do the second solution, like almost as a reflex in here, right? But the first solution requires a lot less mental energy, right? Well, I don't know. It depends on whether or not you really embrace the, you know, adding 0 trick, basically. But adding 0 is how I do a lot of examples here. It's true. Now, you had a question, Nathan?
Yeah.
Nathaniel? Is it Nathan or Nathaniel? I forget.
It really doesn't matter.
It doesn't matter, okay. I will call you, it really doesn't matter then. Very good.
Just don't call me sharp or flat. Anyway, 9.9 over 38.
call you natural. What's the symbol for natural? I should use that in equations. Anyway, number 38?
Yes.
Ah,
Yes.
yeah, this one. This one is, I meant to talk about this one. 9.9,
Yes.
number 38. This one's kind of tough. F of x is, what was it? Can you read it to me again?
Yes. F of x equals x times 1 plus x,
Yeah,
all over 1 minus x quantity squared.
1 minus x quantity squared. All right, so I've done this before, and the solution I came to last time I worked on it with one of you guys, I think it was you, Josh.
Can you get this by divide?
Yeah, well, that's the, well, here, let me just,
That's how I did it.
well, let's see here. So this is x squared plus x, right? Over x squared minus 2x plus 1, you know? So you can either do long division, or you can make a, 2x appear upstairs. So I'm going to rewrite x squared plus x as x squared minus 2x plus 1. But if I do that, to be fair, what do I have to do? I have to add 3x minus 1. And the reason I do that is just to get started. So that gives me f of x is equal to 1 plus 3x minus 1 over, and I'll write it back as 1 minus x squared again. Or, yeah, 1 minus, well, I don't, is it x minus 1 or is it 1 minus x? I don't know, whatever. Those are equal when you square them. So that's nice. At least the 1 will not have its way with us anymore, right? We got that's, at least that's out of the running as a troublemaker. And then I think the way I would go from here, I think the smartest way to go from here, unless I don't know, this is a way to do it anyway, so let's just say that. A over 1 minus x plus b over 1 minus x squared, because that's the partial fractions decomposition here. So I can peel off part of it, which is geometric, directly geometric. Let's do that. So this gives me 3x minus 1 is a times 1 minus x plus b. I put x equals to 1. That gives me 2 equals to b. I put x equals to 0 because, well, I need to do something. That gives me minus 1 is a plus b, which is telling me a is equal to what? -3. Okay, very good. All right, so now we're making progress, believe it or not. So we have f of x is 1. All right, we know what to do with that. Not a big deal. Minus 3 over 1 minus x, right? That piece, again, this is happy. This is geometric, almost done with that piece, right? And then this like slightly less familiar piece, plus 2 over 1 minus x quantity squared. All right? So let's pick on this 2 over 1 minus x squared piece by its lonesome. Let's say g of x is 2 over 1 minus x squared. How we deal with this kind of problem? So here's what we do. Integrate. If we integrate this, we get that the integral of g of x dx is what?
Over 1 subtract x.
Let's see here if I believe you. If I differentiate that, it gets me minus,
Wouldn't you have to do times 1 minus x on the top? Or no? You can either expand it.
here, I'll do it as a u substitution just a second here. So we got 2 dx over 1 minus x squared. Since there's some discussion, let's let u equal 1 minus x. So that's the integral of 2 minus du over u squared, right? Which is minus 2 times the integral of du over u squared, which is minus 2 times minus 1 over u, plus a constant, right?
Yes, to positive 2.
Oh, okay. So, all right. Let's go work through that, right? Yeah, the signs are kind of perilous here. But why did we do that? It's because now at that stage we can apply the geometric series result, right? I can't apply geometric series directly to what I have, but I can apply it to the integral of what I have, right? And so this, of course, is going to give me twice the sum n equals 0 to infinity x to the n, right? But you notice this is the integral of g, it's not g. How do I get back to g? Differentiate, right? Differentiate this, and I get g of x is the sum of 2n x to the n minus 1, n equals 1 to infinity. So that is just the power series for the third part of our function, right? So that is just the power series expansion of that guy, right? Now we have everything we need to put the pieces together. So let's assemble. F of x is 1 minus 3 times the sum, n equals 0 to infinity x to the n, right? Plus the sum n equals 1 to infinity of 2n x to the n minus 1. Putting it all together. Now to complete it, I need to like combine them because they can be combined, right? Let's see here, what should we do? I think we should let this one make a, let's say j equals to n minus 1, right? So that makes n equals to 1 become j equals to 0, right? And that makes n equal to j plus 1. And so what we have here, 1 minus the sum, j equals 0 to infinity of 3 times x to the power j, plus the sum, j equals 0 to infinity of 2 times j plus 1, x to the power j. And of course, to be fair, I should really split off the 0th term here. I've got, what, 1 minus 3 plus 2 plus the sum, j equals 1 to infinity, parentheses, looks like a minus 3 plus 2 times j plus 1 x to the j. I think I can clean that up just a little bit more. That's 0. Their 0th term is 0, isn't it? That's funny. And here we get 2j minus 1. Well, this is a shockingly simple formula. It's just odd numbers times x to the sort of half the odd number power. Yeah?
So you have done this by dividing.
But x plus 1 is not 1 minus x, so they don't just cancel. Well, that is what I did. I mean, so let's see here. X squared plus x squared minus 2x plus 1, right?
Yeah.
So 1. Remainder, which is we're almost out of time, guys.
We also were going to ask, and I think other folks have a question on this as well.
Uh-huh.
This is actually the one I meant to mention first. I didn't see it. 9.8, number 34.
9.8, number 34. That one's tough. I mean, it's got a lot to it, that one. It's a nice problem. Oh, 34. Oh, man, you're going to make me work. Hey.
Well, we got to compress more into those times we have.
34. I think this is the last problem for today.
Your workload is constant, so time increases, problem complexity increases.
Also, my voice is going today. I don't know if I can talk much longer. 30 what?
34. 9.8, 34.
So this is this monstrous n factorial times x plus 1 to the n
No, I didn't even see this.
divided.
Because I did it and I thought I got it right, and now I'm thinking it wrong.
Oh. Yeah. Try this one.
This is number 34 in section 9.8. All right.
So the ratio of things that well enough, but we got confused testing the endpoints.
So ratio test.
What answer did you get?
If you don't mind, I have to work through the ratio test in order to be sure about my endpoint stuff. So so that's going to work out to I took the liberty of noticing that the x plus 1 to the power n is just going to simplify to the absolute value of x plus 1, as it always does. And so that simplifies to n plus 1 divided by, I think all that remains here is that 2n plus 1 because that cancels with that. It just leaves you the last one. And so anyway, that goes to x plus 1 over 2, right, as n goes to infinity. So my ratio test says I need absolute value of x plus 1 over 2 less than 1. So that says that the absolute value of x plus 1 is less than 2, which tells me that the interval of convergence includes 1 minus 2, oh, excuse me, minus 1, minus 2 to minus 1 plus 2, aka minus 3 to 1. It has to be a subset of the IOC. So my endpoints to check are x equals to minus 3, and x equals to 1. So far we agree? Okay. All right, so let's try out the -3. Oh, it's just unpleasant. I mean, it's fine. It's just so much. I need to get new eyes. Let's see here. N factorial. What's -3 plus 1? All right. Oh, this one's, you stupid N factorial. You jerk. So, oh, I see. Yeah, I thought, well, this is easy, obviously, blah, blah, blah. But this is 2 to the n. Well, the question, of course, is if this thing, right, if that goes to 0, we're good, because it's an alternating series, so it converges by alternating series test. But the question is, what happens with that? So that requires some thinking. How many products are there downstairs?
My intuition says n products.
N. Right. If there's 1, it's just 1. If there's 2, it's 1 and 3. If there's 3, it goes 1, 3, 5. You're right. So there's n factors down here, right? And let's see here. Let me just start writing some stuff out. Maybe it'll jar something loose in my mind. So that's n times n minus 1, times n minus 2, 3 times 2 times 1. That's my n factorial. And my 2 is 2 times 2 times 2 times 2. How many of these are there? N-fold, right? So that 1 times 3 times 5.
I found this. Might this be of some help? I completely forgot about this.
Yeah, I think
For a
that's,
different problem.
but it's the same
Yes.
algebra though, right? So what did I see? I saw Nikes.
So it's like the bottom is half a factorial almost, right?
Yeah, right. What was that equation I wrote over there? It's so this is, for some reason, apparent to me another day, but not at the moment. My point here is that this is 2 times 4 times 6 times times 2n minus 2, which, by the way, works out to 2 to the, oh, and I wasn't committing to what k was there, is my, yeah.
That was a big problem.
Oh, I'm not sure I believe this either. I need a 2n factorial upstairs, you know? God. I'm not sure I'm not, this needs work. I mean, there's an idea there,
Yeah.
which, let's see. My intuition here is that this diverges. So how can we make this smaller than something that obviously diverges? Wait a minute. Dang it. How can we make this? How can we make this larger than something? We want to find something smaller that diverges, right? This is greater than insert divergent thing here.
Did you use the F-term test anyhow? Well, that's precisely the problem, right?
Right. We were trying to essentially use the nth term test and show that this is not going to 0.
Is there a better notation with which we could express that denominator?
I don't know. I guess well, it might be productive to think about how that denominator, I mean, we could look at that denominator as n factorial. Well, no, it's not n factorial, but 1 times 3 times 5 times, well, it depends whether n is even or odd, I suppose, but suppose n is odd for the sake of me not going nuts here, okay? N. Well, n plus 2, right? Oh, that's a different n. Dang, damn it. Different n. No. 2n minus 1. Fine. So if n is odd, it appears somewhere here in this list, right? But then this, you can, if we do, 2 times 4 times 6 times times I guess n minus 1, huh?
Would you be able to check for convergence by doing the ratio test again?
No, this is a sequence. So I think that we could write that as n factorial divided by 2 times 4 times 6 times 8 and so forth, all the way up till to n minus 1. And then that gets multiplied by n plus 2, n plus 4. I'm not sure this is productive, but anyway, here's something I'm thinking about trying for n odd. That's a way of rewriting the denominator in terms of an n factorial, right? Then the n factorials cancel because there's an n. So this n factorial would then cancel with that n factorial. Let me just try that. What's that give me? So I've got basically 2 to the n, and there's an n factorial divided by n factorial times this stuff. N factorials cancel, and what are we left with? 2 to the n times 2 times 4 times 6 times 8 times n minus 1 divided by what? N plus 2 times n plus 4 times 2n minus 1. At this point, it becomes obvious to me that it's divergent because I've got a 2 to the n. Well, that's still kind of a well, no, but that's still kind of like part of a factorial in some sense, right? I mean, it's not n minus 1 factorial, but it's like part of n minus 1 factorial. It's like half of n minus 1 factorial, right? Anyway, I'm pretty sure that that's divergent. And I'm also pretty sure that there's an easier argument that could be given here. I'm just not seeing it at the moment. It doesn't mean that there's not an argument to find. It means I can't find it at the moment.
Could we take Joshua's advice, though, and do ratio test on the original series? Having ratio test on the original series doesn't work.
But we already did that. That would have been covered by the ratio test we did for arbitrary x. We're just choosing a. We're just choosing a. Yeah, this is the case that the ratio test works out to 1. Yeah. We already used the ratio test. This is when the ratio test is inconclusive. We're forced to do something else. There's probably something you can compare this to see that it's divergent. So anyway, I'm going to shut up about that. So I guess we're done.